Hello everyone. Today I'm going to configure the most demanded configurations in OSPF domain. I'm going to start with the multi-area OSPF configuration. Then I'll explain the difference between the broadcast and point-to-point network types. I'm also going to explain different roles of routers, ABR, ASBR. We'll also analyze database description in which we see different kind of LSAs and routers are responsible to produce those LSAs. So let me explain the topology first. In this topology, you can see that there are three different areas. Area 0 backbone area, Area 1 and Area 2. There is a precondition that all the areas must be connected with the backbone area, Area 0. So through router R1 and R2, both areas are connected with Area 0. Then we have an external connection through ISP, which is through router number 3. We are going to configure multi-area OSPF on R1 and R2. On R3, we are going to configure static route, and that static route shall be advertised within our OSPF domain. So let's begin with the configuration. Enable config T do show IP protocols. Just let's make sure that there is no routing protocol is configured yet. As I told you, OSPF can be configured in two different ways. One is through the global configuration mode, and another method is through the interface mode. So on router R1, I'm going to use the global configuration mode, and on router R2, I'm going to use the interface mode. So router OSPF1 network 1.1.1.1 default wildcard mask 0.0.0.0 area 1 network 192.168.12.0.0.0. Now this is slash 30, which means subnet mask will be 252 in the last octet. And opposite, if you minus 255 minus 252, it is 3. So wildcard mask 4/3 network is 0.0.0.3. If you're facing a difficulty in calculating the wildcard mask, I can create a separate video in wildcard mask from the subnet mask. In a similar way, I have configured the decimal to binary, binary to decimal conversion videos. And then area 0. You have to advertise all connected networks. So we have advertised 1.1.1 network, 192.168, and the third network 123.0.0.0. Now this is slash 29. Slash 29 means 248 in the last octet. 255 minus 248, it becomes 7. So 0.0.0.7 area 0 is your correct command. And if we do not configure the router ID manually, it automatically picks highest configured loopback address, which is 1.1.1.1 in our case. And our configuration complete for this router. And let's move to the router number R2. I'm going to configure the configuration through the interface mode. Enable show IP interface brief config terminal interface range G0/0-1 IP OSPF1 area 0 interface loopback 0 IP OSPF1 area 1 and right. On router number 3, I'm going to use global configuration method same as we used on the R1. Enable config T router OSPF1. I'm going to configure router ID manually here. Network 3.3.3.3, 0.0.0.0, area 0, network 123.0.0.0, 0.0.0.0.7, area 0. And right, and we have complete our OSPF configuration. You have seen that how can we create multi-area OSPF. Full neighborship has been configured with router number 2 or router number 1 as well. So let's analyze show IP OSPF neighbors. You can see that router number 1 and router number 2 has created full neighborship. Router number 1 is DR, router number 2 is BDR. In this case, router R3 will become DR other. If router do not become DR or BDR, all the remaining routers become DR other. And DR other routers do not make full neighborship with each other. DR other routers only make full neighborship with DRs and BDRs. So let's analyze the neighborship in the router number R2. Show IP OSPF neighbor. So in this case, you can see router number R1, full DR, full DR, other is router number R3. And what does mean by full and dash? It means that there is a direct link, point-to-point link between router number 1 and router number 2. Because in the point-to-point link, there are no DR, BDR elections, so you can see this slash. How can you make sure that it is a point-to-point link? So IP OSPF interface brief. From this command, you can see that interface G0/0. Interface G0/0 is point-to-point. If you want to see the details, show IP OSPF interface G0/0. And you can verify that network type is point-to-point here. And if the network type is point-to-point, there are no DR and BDR elections. And if there are no DR-BDR election, then this interface do not produce type 2 LSAs, which are basically produced by the DRs. So let's analyze the LSAs. Show IP OSPF database. In this database, you can see router LSA, type 1 LSAs, which are produced by every router. Router number 1, router number 2, router number 3. Type 2 LSAs are only produced by DRs. Since R1 router is the DR, it is advertising this network. Then there are summary network LSA type 3 LSAs. These are produced by ABRs, area boundary router. The router which are connecting two different areas together are called area boundary router, and they produce type 3 ILSAs. So in this case, router number R1 and router number R2 are producing type 3 ILSAs. Then for area number 1, we have router number 2 advertising this. I think we have done some misconfiguration. This network was in area 2. So let me correct this configuration. Show run type section OSPF. Yes, we have accidentally configured this into area 1. Config T interface L0, no IP OSPF1 area 1 and IP OSPF1 area 2. Now we have made the correction and let's analyze the LSAs one more time. Show IP OSPF database. Okay, so now type 1 LSA, all router will produce these LSAs. Type 2 LSAs produced by the DRs only. Type 3 LSAs produced by the area boundary routers. And now in area number 2, network 2.2.2 is advertised by the router number 2. And these are the summary network LSAs for area number 2. Similarly, if you go to the ABR, show IP OSPF database, you can see the network summary LSAs produced by the router number 1. These are the different roles of the router, and this is how each router advertise their own connected network. Now let's analyze OSPF database on router number R3. Show IP OSPF database. Now you can see that all the routers are advertising router LSAs, router 1 advertising type 2 LSAs, and type 3 LSAs are being advertised by router number 1 and router number 2. Now if you see show IP route OSPF, network 1.1.1, 2.2.2.2, and 192.168.12 are being learned through the OSPF. O means the OSPF, IA means inter area. If you want to know about these symbols, you can directly write this command show IP route, and here you can see the meaning of each letter. O mean OSPF, IA means OSPF inter area. Now every router can reach all of the internal network. For example, if you ping from R1 PING 3.3.3.3, you can see the ping is successful. Similarly, if you ping from R1 to 2.2.2.2, you can see ping will be successful. And similarly from R2, if you ping R3 3.3.3.3, ping between R2 and R3 is also successful. So this is the benefit of dividing the network into different areas. Now, router 1 and router 2 are managing all the network within their areas. Router 3 only need to know that, okay, these areas are being advertised by router number 1 and these networks are being advertised by router number 2. Whatever traffic belongs to the networks managed by router number 1, router 3 can directly transfer those to the R1 and then R1 will manage rest of the part within that area. Router 3 do not need to worry about any of those networks. So now the big question comes, how our internal devices be able to communicate with internet? Because right now, nobody knows about the ISP. So what we can do, we can configure the static route from R3 to the pointing towards the ISP. Config the IP route 0.0.0.0, 0.0.0.0.0, 203.0.113.1. I think I have configured 1 as our next hop on the ISP. Okay, so now if you see that show IP, do show, do show IP route. Now the static route is configured. Gateway of last resort is now configured. But if we see router number R1 and R2, show IP route, they do not know how to reach the outer network, how to reach the internet. The same problem is with the router number R2, show IP OSPF route, show IP route. Gateway of last resort is not set. So in this case, we want to assign ASBR role, autonomous system boundary router role to the R3. When this role is assigned to R3, R3 will start advertising this external network to the OSPF, which means that with those configuration, R1 and R2 automatically knows about outside network. Let me show you how can we achieve that. We go to router OSPF 1 and there is single command, default information originate. That's it. With this command on ASBR, now our default route shall be automatically advertised to R1 and R2. And if you see the routing table again, show IP route, you can see that gateway of last resort is configured and here to OSPF E2 type 2, OSPF external type 2. So in this case, if we try to ping 8.8.8.8, our ping should be successful. But right now our ISP do not know how to reach R1. So we have to configure temporary route back. In real network, it is not required, but in the lab environment, we need this configuration. So I'm going to configure a route, static route, config t IP route 0.0.0.0, 0.0.0.0, 203.0.113.2. And now if I will ping again, and now you can see that ping is successful. So now router R1 exactly knows how to reach 8.8. Now let's analyze LSDB one more time from R1's perspective. Show IP OSPF database. In this database, now we can see that there is another type 5 LSA is also available, which is being advertised by router number 3 because it has assigned the role of ASBR, autonomous system boundary router. So now all the routers knows within the OSPF that if we want to send any communication out of our own network, we will send it to the router number 3 and router number 3 will manage all the traffic from there onward. Similarly, when traffic come back from ISP, we see that router 3 was able to route it towards the router number R1. So this is the beauty of hierarchical model of the OSPF. And if you find any problem, let me know in the comments. I will explain them in my next video. If you want to learn more about OSPF or other concepts regarding CCNA and CCNP, I will highly recommend you to visit the website packetmentor.com. You go to the search menu or write the topic which you are looking for, and then just click on the required topic. And you can find 5 different options. In the lesson, you can study all the theoretical details. Simulator can help you to visualize the concepts important for understanding or troubleshooting during the CCN exam. Quiz section, you can evaluate your knowledge Hands-on lab give you immediate access to the labs where you can start writing commands immediately, enable conflict key in the same way as you do at the Cisco CLI. And packet tracer labs are the actual lab. If you are confident enough that you have covered all the related studies, you can download these labs and practice yourself. If you're facing problem in any of the topic, let me know in your comments. I will make a separate video on that topic. Hope to see you in next video.